uh, from this title, we're doing the proof of the area of a circle, which is 2 pi r squared. But we don't know that yet. We have to prove it. And we're going to do that given my definition of Riemann sum. So let's first start with a circle. So you see here, a circle is defined as a constant distance from a certain point, a set of all points such that there are distance away. Now, let's look at this radius, which is r. Let's split this radius into n pieces such that this piece right here and all the other pieces, this length of this piece, which is the same as here, this is just equal to r over n, right? Now, keeping that in mind, let's draw the corresponding circles of all these individual radiuses that we have split up, right? So the key to this is to draw very well, so you don't get confused. I'm shit at drawing, so please pardon me. I tried doing this at home. This is really fucking hard. Okay, now we have this abomination, and let's try to actually think about it. What we've done here is to split up the circle into infinitesimally small rings, infinitesimally thin rings, or over n thick, to be precise. Right? And let's take this outer ring, the first ring, and try to unwrap it like a rectangle. Right? So the width of this rectangle is as follows. It's r over n, right? And the height is the perimeter of it, which is 2 pi r. Now, what's the area of this? This is a rectangle, space times height, right? So this is equal to the area of this entire thing is 2 pi r times r over n. Now, what about the second rectangle? Or at least the pretend rectangle. This is not quite a rectangle. It's a little like this. It's not perfectly straight. There's always going to be a little curve right there. But we're going to. But as the n approaches infinity, it gets more and more treated like a rectangle, which I think is the least rigorous part of this proof right here. But I like it nonetheless. Maybe you can do a little investigation here, some real analysis to prove that this is a rectangle. So the second rectangle has perimeter 2 pi minus r over n, because this radius, it is just this radius, or minus this distance right here, r over n, and you have this corresponding circle to that radius, which concentrates all these other circles. Now, thereby you have rectangle with this as the height, so r minus r over n, with the thickness to be r over n. This tasteful thickness. Now, I've got the 2 pi. The radius is r minus r over n, but the perimeter is 2 pi times that, 2 pi times the radius, because that's the definition of pi. Now, the next rectangle, where you do the same thing, it is 2 pi times r minus 2 of these, right? So you get this radius instead. Right? That's the height, and the base is the same. Now, we can do this all the way up to continuously subtracting r n from the radius, so that we get, let's maybe see this clearly, 2 pi r minus k r over n as the height times r over n, right? And k goes up to n. That's where it stops. We all want to add up all these areas, so we can rewrite this with the corresponding heights and thicknesses. We get 2 pi r times r over n, 2 pi r minus r over n times r over n. We add up these areas together. 2 pi r minus 2r over n times r over n, all the way up to this. Now this is just a series, so we can rewrite this in signal notation. So let's erase all of this, but don't forget it. So in other words, the area of this circle can be written as sigma from k equals 1 to n, well actually from 0, because we're starting from here, and 2 pi r minus r k r over n times r over n. We can factor out the 2 pi because, algebra. You can convince yourself that you can do that yourself at home by expanding it and using algebra, use your brain. And note that this looks very similar to this. Let's try to define this in terms of this. Now, we have a here, right? So we're going to set a equal to 0 in this case, and b equal to r. So r over n equals b minus a over n. This one corresponds to this, and this is a function of b minus a over n. A function of kb minus a over n, which is the requirement for the Riemann sum. So this is f of a is 0, so this cancels out, and this one, and you can sub an r there, and you have k r over n. So given this, we can solve for the function r k r over n is equal to f of k r over n. Let's make a substitution. Make this x, and you have r minus x is equal to f of x. See f of x right here? You can sub all this into the integral. So this is equal to 2 pi integral from 0 to r of the function r minus x. Right? And the integral, it's a very easy integral. It's practically trivial. So using a sum rule for integral, we get 2 pi times this entire expression here. Let's bring it a little closer. And integral from 0 to r dx minus integral from 0 to r of x is equal to this. You can solve this yourself. It's pretty trivial that it's r squared minus x squared over 2 from 0 to r. So you can plug in r here, if you plug in 0, the entire expression will be 0, so you can ignore that, and you get 2 pi r squared minus r squared over 2, which is equal to 2 pi r squared over 2. And this is pi r squared. So it's these to cancel out. Doesn't that seem awful familiar? Anyways, thank you for watching.